Okay, for the next step, we will create a section for the beam for the project. The first we can estimate from the ACI the section pre-estimation. For the beam section, we can take the clearance span, and we can take the interval or number up from 1 over 15 to 1 over 10 multiplied by length to calculate for the dip, and also the interval 0.3 to 0.6 multiplied by the dip of the beam to get the Y of the beam. And slab thickness for the same. We can take the parameter. The parameter is equal to 2 times of the total length, long side and short side of slab, and divide by 108 to get the minimum thickness of the slab. For our project, now I will create the beam for the X direction. My longest span will be 4.4 meters. My longest span is 4.4. So my beam depth should be between 300 to 400, 200 to 440. So I will select about 400. Yes, 400 millimeter is equal to 40 centimeter. So, and for the beam Y, after taking 40 centimeter, I will my beam Y will be between 120 to 240. So I will choose the 20 centimeter equal to 200 millimeter for the beam Y. So my beam section should be 20 by 40. I go back to the Etabs. The same, we go to define section property, frame section, and here this is the default, so I will not need any one, so I will delete all. Delete section. Delete section. Okay. Yes, only one. So I will add new property, and the concrete will be the rectangular. This should be the concrete. Yeah, concrete rectangular, and select the rectangular section, and yes, the property name I will put OP reinforcement beam, reinforced concrete beam. Should be 20 by 40. By 40. Yep. So the material should be the 25. Sorry. And the color, you can choose any color you want. So I will ignore and take a default. And the section dimension, the depth will be 400 the millimeter, and the Y to be 200 millimeter. And here modify, and so modifier I will not touch at the moment. We will talk more later. And reinforcement modifier here is not column. I should be beam only. Yep. And material should be for the long dinner bar. I will take 400, and confinement is minute stirrup. It should be a 230. Cover to longitudinal rebar centroid. It means the cover from the edge of the beam, of the concrete beam, to the center of the first reinforcement, long reinforcement before bar. So if my cover about 30 millimeter, and my default bar, I just estimate for this time about 16. So 16 divided by 2 should be 8. here. So the cover should be 30 and plus my deformer I will choose the 16 deformer and divide by 2. Sorry, so be 16 divided by 2. No, 16 divided by 2 about h. So my cover 30 I plus my stirrup about 8 diameter, 8 millimeter, also plus 8 again for the deformer center of deformer, so equal to 46. So 46 I will choose the 50 a bit higher. Okay, the top and bottom will be the same. Then okay, and okay, yes, this one we can delete. Yeah. Okay, so we go to the y direction. The y direction I will check my longest span should be 5.24. Yeah. The same process, 5.24. So my beam depth should be between 350 to 524. So I will same choose 400 because 400 also the bigger than 350. Look, this time I just estimate the first. Okay. So my beam depth, my beam section at the y direction be the same beam section at the x direction. So I will not create another one. Okay. Okay. Yep. Then the next step we will create the section for the column. From here, column bearing capacity. So the weight of the column we can just estimate. For example, the column is column 1. We can find the critical section for the column. That means we divide this span and divide this span. So the critical section for this column should be from here. Middle here. And we can find the here. You can see 6.2. 6.2 it should be okay. So we will find the critical section for this column. Now I will dimension this should be 6.2. Yeah, 6.2 divided by 2. 6.2 divided by 2 here. From here we can find the middle. And also 3.22 divided by 2. Can find 3.22 divided by 2. Same. From here. And also displace 4.4 divided by 2. 4.4 divided by 2. And also 4.4 divided by 2. And we spend 5.18 divided by 2. Yep. 5.18 by 2. Yep. So fill the critical section should be Yes, so be this area. Yeah, this is the critical section that this column will be resisted. Okay, now back to MathCAD. So the surface should be okay. This is the area, and 120 I assume the slab thickness, and 14 or 17 is the number story of the building, and 24 the concrete density. Yeah, critical area of slab. We can find. Sorry, this would be 300. Yep, should go with the me 440 by 1380 like this. Can find the area section A. Yeah. So, and the line load for 17 floor will be 857.314. Super dead load, we can the area multiply by 17 floor and multiply by 2.72. 2.72 is the superimposed load on the floor. We can find from here. Got dead load on the floor. We can combine from the mortar, ceramic, ceiling, something. So 2.42. So I will adjust this and check here. Ceiling 2.2. 2.42. Yep, and total surface line load and superimposed load should be 2,890 kilonewton. And assuming dimensional column will be 500 to 500. This is the first assuming. And then we and the height 3.5. I take the longest height in the building, and column surface should be here 390 16th floor, because we have 17 but the column will be counted only 16. Total actual load on a column total 3,226. And assuming the column dimensional column will be we take a finder and finder. Same here. Or we can, yeah, we can be equal to 500 millimeter. So this the value we take from here automatically for 500. Yeah. And rebar will be 16. Just in rebar I 400. Complete strength 30 megapascal. Reduction factor 0.75, and number of rebar 20 number of rebar. And the number of rebar, no, let's calculate first. We assume our column should be 500 by 500. Yes. And our core from the edge to the center of deform bar should be 500 or 50, sorry, 50, and diameter I assuming 16 millimeter. One solid. Yeah, can move here to the center. One and mirror, and so here from here it's 500 millimeter. So I will arrange about 5 rebar along this edge. We can divide this line to be 4. Yeah. Okay. And another side also the same. And here because it's rectangular. Yep. Yeah, rebar to be like this. So I count 2, 4, 5, 10, 13 and 16. So about 16 rebar for this column. Sorry. Okay. 16 rebar. So the sectional column will be by hash, by h. Total section of rebar here, and the rebar percentages for the column according to the ACI, the maximum reinforcement ratio should be from 1 to 8% of the cross section of the column. 1 to 8. And allowable capacity of column we can find from this the formula. So the allowable capacity of the column should be bigger than the total shear load on the column. So the column is safe. Correct. Yeah. So back to the item. I can define the section property, frame section. I will add new property, concrete rectangular, concrete section, and name should be reinforcement column 550 by 50, and the concrete should be 30. Here change to 500 millimeter, 500, and the same modifier and stiffness I will talk later how I keep default. Modify and sorry bar, the column and the form bar 400, and confinement bar is the stirrup. I can assume that the stirrups will be maximum diameter 8 millimeter, so still around bar, so choose 275. Reinforcement configuration, rectangular section, stirrup bar tie, we can tie together. And the first I will check only, not design, checks. And clear cover to clear cover for confinement bar. We can count this cover. We can count from here up to should be a stirrup line from here. Stirrup bar should be here. If we consider both at the rear and side stirrup, yes. And stirrup dimension should be the 8 millimeter here. This line, sorry, H. Okay. This line should be the stirrup. So we can assume that the cover of the column from here to here, the surface of the columns, we take about 30 millimeter clear space for the cover. So I will put here about 30, and click over to and the program should be count to the center out the speed up. So h divided by 2 is 4, so it's 35. You can find the 35. Yep. And the number will be 5 along 3 direction. This 3 direction, 8 direction, and from here about 3. Why 3? Because we can look at the AutoCAD here already from the 3 direction and also the 3 direction. So the 2 direction on this left 3, 1 to 3. Yep, 3. And long bar will be 16. Corner bar also the same, will be 16 corner. And speed up here, bar h. And I provide spacing of 150, and if we consider I can add 2 legs more, so the leg will be 4, because should be here 1 more, 1, 2, 3, 4, 4 legs each side. This be the same. Leg direction, leg 4, y direction, so leg also 4. So 4. Yeah. Okay. Sorry. Number. Oh, okay. Sorry. 5 is the same. We count at the corner same. So yeah, it's correct. This is a bit confused with the SpColum, because SpColum when we count the X direction again, the from Y direction we omit this, but the Etabs we count the same. So along X and along Y will be the same number, 5 and 5. Okay. Yes, we got beam and column section already. And okay. Now we will go to make a concrete slab thickness. A pre-section we can talk on the beginning. The concrete slab thickness estimation should be the parameter divided by 100H. And the long side, back to my project, I choose one span with the longest span. So from H to be 4.4 and from Y to be 5.24. To be here. This span also. So the short span will be long span will be 5.24 and short span is 4.4. So the selection is minimum is 107, so I will choose 120 millimeter. Okay, Etabs define section property slab section. Slab 1 lid add new. I can say as 12 centimeter. Concrete will be 25. Yep. And slab 120 millimeter. Says thin. Okay. And plank I can delete the property. Yep. Okay. And the next we will create for the shear wall section. So the wall I will create for thickness about 20. We can estimate it should be 20 millimeter first, or modify, or we can add new property. Wall 20, 30 megapascal, 200 millimeters as in, and modifier later we will talk. Okay, and go on, we can delete.